Welcome back. This is Advanced Geometry with Mrs. RRubright. Today's lesson is 11.5, Explore Solids. So we're going to start with some vocabulary. A polyhedron is a solid that is bounded by polygons called faces that enclose a single region of space. The plural for this is polyhedra or polyhedrons. An edge is the intersection of two faces. That's where they come together. The intersection of two faces forms a line, and that line is called an edge. The vertex of a polyhedron is a point where three or more edges meet. They come to a point. They come to a vertex. All right, I'm going to bring out my manipulatives really quick just to show you guys. I'm going to pause the video. All right, so there's different types of solids. So we have polyhedra, which include our prisms and our pyramids, right? They have edges, like here. This is an edge. This is a vertex. This has rectangular faces. This one has triangular faces. It has its vertices, right? It has its edges. Over here, these are not polyhedra. The reason these are not polyhedra is because they have these rounded edges. So all of our edges, for it to be a polyhedra, must be straight lines. Right here, this is a circle. A circle is not a straight line, so therefore, this is not a polyhedra. So your cones, your cylinders, and your spheres, those are not going to be considered polyhedra. All right, so tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. So I want you guys to look at this. When you're looking at this, if it is a prism, it will have for a prism, it'll have two bases and all rectangular faces. The number of rectangular faces will equal the number of sides the bases have. The base names the shape. So on this one, which two are the same? These two, right? This is your base. Your base names the shape. So these two are rectangles. I know this because they have opposite sides are equal and they have right angles. So this is a rectangular prism. It has these two rectangular bases and then it has these four rectangles connecting them. So we know that this is a rectangular prism. Okay? So what do we know about the number of faces? Vertices and edges. What do we know about our faces, our vertices, and our edges? Take a second to look at this, write it down, and then I'm going to call on someone. Faces, vertices, and edges. How many sides does this have?
6.
It has the 4 faces plus the 2 bases, which is a total of 6 faces. They count the bases as faces also, guys. All right, so then what about vertices? What'd you get? 8. 1, 2, 3, 4, and then the 4 over here. 5, ooh, I didn't mean to do that, 6, 7, 8. 8 vertexes, right? 8 vertices. What about edges? Well, we did this one. 1, 2, 3, 4, 5, 6, 7, 8, and then the 4 connecting them. 9, 10, 11, 12. All right, what is this? This one is a pyramid. It has one base. The base names the shape. What is it? 1, 2, 3, 4, 5, 6. A 6-sided base is a hexagon. So this is a hexagonal pyramid. Hexagonal pyramid. So it has, in terms of faces, what shapes are going to make up a hexagonal pyramid? 1 hexagon and how many triangles? 6 triangles, 1 for each side. So there's 7 faces. In terms of vertices, there's the 6 plus 1, there's 7. And edges, there's going to be the 6 down here and the 6 coming up, 12. Make sense? All right, what is this? It is a cone. It is not a polyhedron. Tell whether the solid is a polyhedron. If it is, name the polyhedron and name the number of faces, vertices, and edges. What is this? It's a triangular pyramid, so it has a triangle base.
No, it's square.
It is a square pyramid. All right, so it has one square and how many triangles? 4, one for each side. So there's 5 faces. How many vertices? 5, one for each corner of the bottom, and then the one that they all come up to. 5. How many edges? 8. The 4 for the square, and then the 4 coming up to the point. All right, what is this? Half of a cylinder. Is it a polyhedron? No, because it has curved sides. It has a curved square. What? That makes no sense. This textbook is fabulous, huh? So it is not a polyhedron. It has a curved side, so it's not a polyhedron, okay? All of the edges must be straight lines. All right, so your textbook publisher comes up with some interesting things to say, I guess. All right, so what about this one? What would this one be called? Think about what shapes do you have. What shapes do you have? You have 2 what? 2 triangles and what? 3 rectangles. So do you have 1 base or 2 bases? 2. The base names the shape. This is a triangular what? Prism, because prisms are made up of rectangles. Pyramids are made up of triangles, and they come to a point. This is a triangular prism. All right, so we have faces, vertices, and edges. How many faces? 5. Vertices. How many vertices? 6. Good. Edges. 1, 2, 3, 4, 5, 6, and the 3 connecting them. 7, 8, 9. Euler's theorem. The number of faces, vertices, and edges of a polyhedron are related by the formula faces plus vertices equals edges plus 2. All right, so faces plus vertices equals edges plus 2. So if we were going to plug this in to see what happens, so faces, let me get a darker color, faces plus vertices equals edges plus 2. Does this work? 14 equals 14. It does. So this is a nice little way that you can check and make sure you didn't make any silly mistakes. Your faces plus vertices has to equal your edges plus 2. Or you mess something up. See this one. House construction. Find the number of edges on the frame of the house. All right, so how many edges? What's going on here? How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then how many connecting them? 5 more, right? 11, 12, 13, 14, 15. 15. All right, so how many edges on the frame of the house? So then they want to know, they said the frame has 1 face as its foundation, 4 that make up its walls, and 2 that make up its roof, for a total of 7 faces, right? Because we have the 2 pentagons, 1, 2, 3, 4, 5, 6, and then the floor, 7. That makes no sense. Hold on. Yeah, it does. 1, 2, 3, 4, 5, 6, and the floor, 7. What? What side's open? That's one piece. This right here is one pentagon. This is all one pentagon. This is a pentagon. This is a pentagon. This is a pentagonal what? A pentagonal prism. You have 2 pentagons, and you have how many rectangles connecting the 2 pentagons? 5. 5, 6, 7. 7 faces. So you have 7 faces. You have 15 edges. Right? How many vertices? 1, 2, 3, 4, 5. Have you guys seen the pattern yet? 6, 7, 8, 9, 10. If it's a prism, the number of vertices is going to be the number of sides of the base times 2. Right? If it's a pyramid, it's the number of sides of the base plus 1. For edges, for a prism, it's the number of sides of the base times 3. Right? All right, let's throw this into Euler's. So we had the faces were 7, the vertices were 10. The edges, they are solving for edges without counting. But if we looked ours up and we got 15, so 15 plus 2 is 17, 17 equals 17, so we know we're good. If you didn't want to count the edges, you could have always just thrown it into this formula and solved for E, which is what they did. All right, so find the number of faces, vertices, and edges of the regular octahedron. All right, so faces, vertices, and edges. How many faces? We have 1, 2, 3, 4, and 4 is how many? 8. Vertices, 1 plus 4 plus 1. Edges, 4, 4, and 4. So let's plug it into the formula and see what happens. They said 6 vertices. 4. Oh, I can't count. And nobody in here corrected me. What's up? 4 vertices plus 2. 6. All right. So if we would have put the 8, 8, and 12, we would have gotten Euler's formula wrong, which would have told us we messed up. So we write Euler's formula, and we plug in 8 plus 6 is 14. 14 equals 12 plus 2, so we know we're good. If I wouldn't have caught that this was 6 already, if I would have kept this as 8, we would have had 16 equaling 14, which is not true, so then we would have been able to go back and figure out where we went wrong. Describe the shape formed by the intersection of the plane and the cube. So what shape is this when I slice it in half? This purple area right here. What shape is that? It's a cube, so therefore that is a square. Good. How about this one? That is so not a square. It is a rectangle. Good. So this purple area right here, this is a rectangle. That cross section when you slice it. How about this one? Good job. That is a trapezoid. Triangle. Good.
Circle.
Good job. Circle. That is a hexagon. Good job. So this cross section is a hexagon. What is this shape? What is this shape? The whole thing. Hexagonal prism. Good. And this one was a cone, not a polyhedron. This one was a cube. Good, good. Those are all cubes. And that is everything on our lesson on 11.5, Explore Solids. We hope you enjoyed the lesson. Please subscribe and like our video, and have a great day.